Okay, so next up is number 3 in the 2019 AP Statistics for Response. And number 3 says, a medical researcher surveyed a large group of men and women about whether they take medicine as prescribed. The responses were categorized as never, sometimes, or always, and the relative frequency of each category is shown in the table. So it's interesting. So instead of knowing how many people said it, they're telling us the proportion of people that said it in each group. And notice the total proportion is 1. So if you want to look at it in percentages, 47% of all people surveyed were men, 53% were women, 12% said never out of men and women, 34% said sometimes, and 54% said always. Now, question A. It's a probability question. One person from those surveys will be chosen at random. A. 1. What is the probability that the person selected will be someone whose response is never and woman? So we're looking for the probability that they never take their medicine and they are a woman. Well, let's look at the table. What proportion of people never take their medicine and are women? Done. 0.0636. Next, what is the probability that the person selected will be someone whose response is never or woman? So the probability that they never take their medicine or that they're woman. Well, on the reference sheet, you get this formula. It's the probability of never plus the probability of woman minus the ones that we count twice, which is never and women, which is nice because we just calculated never and woman 0.0636. So what proportion of people never take their medicine? 0.12. What proportion of people are women? 0.53. What people did we count twice? 0.0636. So we get 0.12 plus 0.53. Let's erase this. Minus 0.0636. Let's see, 0.12 plus 0.53 minus 0.0636, 0.5864. Okay, part C. What is the probability that a person selected will be someone whose response is never, given that they are women? So we have conditional probability. So never, given that they are women. And this is also on your reference sheet. That's the probability of never and woman over probability of woman. Well, what do we got there? Let's see. Never and woman, 0.0636. Probability woman, 0.53. So if we're only looking at the women, what percentage of those women never take their medicine? That's the question. So it's 0.0636 divided by 0.53, 12%. So 12% of those 53% never take their medicine. Sorry. Good. Part B. For the people surveyed, are the events of being a person whose response is never and being a woman independent, and justify your answer? Now, there are a few different ways to check independence, but I think the easiest way here, if you're able to, is it's independent. Let's put, B, independent if the probability of, we're looking at never and woman, the probability of never taking your prescription as you should times the probability of being a woman, does that equal the probability of never and woman? If you can multiply two events and the probability of them both happening equals that, then they are independent. For example, think of independent events. Flipping a coin, getting heads, rolling a die, getting 2. Those events do not affect each other. So what's the probability of both happening? Heads, 1 out of 2. Getting a 2, 1 out of 6. That's 1 out of 12. That is the probability of getting a heads and a 2. So these are independent if this is true. Well, let's see. What's the probability of, well, N and W, we know that already, we did this, is 0.0636. The probability of never, that's 12%. The probability of being a woman in this survey, 0.53. When you multiply those, you get 0.0636. So then I would just write, yes, the events being a woman and never taking medicine, never taking your prescription, are independent, since the probability of never, you know what, I don't even have to because it says justify and we showed it and therefore we're stating it. I think that's going to be enough. And then last part, part C. And now part C is something we haven't seen in a long time. It says, assume that in a large population, the probability that a person will always take their medicine as prescribed is 0.54. If 5 people are selected at random from the population, what is the probability that at least 4 of the 5 will always take their medicine as prescribed and support your answer? So, this is something we have not seen, like I just said. This is something called a binomial distribution. Now, how do I know that it's binomial distribution? Well, there's a little acronym again. It's BINS. B stands for binary. Binary means it's either success or fail. In this case, it's either they always take their medicine as prescribed or not. I, independent, right? Independence, how do we check for independent? Make sure you're not sampling too big of a sample size. Well, 5 is your sample size. 10 times 5 is 50. Is 50 less than a large population? Yes, therefore independent. N, set number of trials. What is the number of trials here? The number of people, 5. And S, is the probability of success the same for each person? Yes, just because one person says I always take it does not change this. It is set probability. So, really what they're saying here is what is the probability that at least 4 people always take medicine? And what you got to think about is this. And if you might remember this, what I like to do is I like to write 0, 1, 2, 3, 4, 5. So we're looking for at least 4. So what are we looking for? We're looking for 4 or 5. Now, if you remember in your calculator, we have something called binomial CDF and binomial PDF, right? Just some notes here. Binomial, and you don't have to write this on your test, binomial CDF is cumulative, and that goes from some number or below. Binomial PDF finds exactly that number of trials. So what we want here, the probability at least 4 always take their medicine is the probability that exactly 4 plus the probability of exactly 5. So the way to do this, you could do it 2 different ways. We could do binomial PDF for 4, PDF for 5, add them together. Or you could do 1 minus binomial CDF when x equals 3. Either one is fine, it doesn't really matter. When it's only 2 things, generally I just do PDF plus PDF. It really doesn't matter. So let's see. So we got second distribution, binomial PDF. You'll see, remember what the menu looks like. Trials, P, and X value. So here, trials was going to be 5. Sorry for this, wasn't prepared. P, probability of success, it said was 0.54. And then X value, you could do exactly 4. Find this value, do it again with 5, and add them together. So that's the probability that exactly 4 to the 5 always take their prescription.